Okay, so we have to talk about the remainder factor theorem. If you go back to the previous exercise, you have seen that after performing a long division, then you see that what is the remainder, and if the divisor that was a factor or not. Okay. Now suppose, let me take a question from here. Now we have, just let me pause this for a minute. So all this expression is divided by x plus 1. You have to see that how cool are the mathematicians. Now first, let me do that all long division here. Okay. So we have this x is per 4 minus 3x.
Sorry, कौन से exercise का question है?
From exercise 1E. Okay. Right now you don't need to look at the book, just look at the board and just keep on copying the things with that. Okay. So I just want to show you that how cool is this remainder factor theorem. Okay, now so this is just a division of your algebraic division. So you make a check that both these expressions have to be in descending order. Okay, so now this is going to be x cube over here. So x cube into x will give us x is per 4 and then plus x cube. Okay, I changed the signs here. These are cancelled. So we have minus 4x cubed. And then I have minus 4x squared. So this should be minus 4x squared over here. Okay. So this is minus 4x cubed and minus 4x squared. So I have to change the signs. So this is plus, plus, they're all cancelled. So we move these down here. So we have 5x plus 5. So this is going to be plus 5 over here. So this is 5x plus 5. And then I change the signs. So you see that after such a long division, we have reached the conclusion, yes, this x plus 1 is a factor of this given polynomial. Now, how does the factor theorem help us to do that very quickly? We just name this thing as f of x. I'm just going to write that quickly, x to the power 4 minus 3x cubed minus 4x squared plus 5x and then plus 5, okay? So when you're dividing this with x plus 1, so you will basically be finding f of minus 1. Now please look at this very carefully. If you're dividing this, suppose you're dividing this with, let's say, x minus 1. So then you will have to find f of 1. If you're dividing with, let's say, 2x plus 1, so you will find f of minus half. Okay, is it clear to you? For example, if you just divide it by x, so you will find f of 0. So we're dividing this by this x plus 1. So we're going to find f of minus 1. So I'll be substituting all these x's with the minus 1. So minus 1 raised to power 4. Abhi, like with the practice, you know, you will not even need to show this step. You can just write this mentally here. Minus, I mean, this working here, putting the powers on them. So you see that minus 1 raised to 4. Like you can skip this step and write this one directly. This is 1. Minus 3 into minus 1 is plus 3. And minus 4 into 1 is minus 4. 5 into minus 1 is minus 5 and plus 5. So what is the sum of all these numbers, guys? We see that this is all equal to 0. So we didn't have... Yeah.
I don't get where minus 1 came from.
Yeah, look at this. When you're dividing it by x plus 1, just put that x plus 1 equal to 0. What do you get? X equal to minus 1. So when you divide it, I have given you 3 more examples here, beta. When you're dividing it by x plus 1, you find f of minus 1. When you're dividing by x minus 1, that will be f of 1. And when you're dividing by 2x plus 1, so फिर क्या होएगा? F of minus half. And if it is just x, So this will be f of 0. Now, one thing you must
Okay,
notice
thank you, sir.
expressions that the remainder and factor theorem only work with the linear expressions. We cannot use the remainder factor theorem when the divisor is a non-linear expression. Got it, bacho? Yes? So, let me move this a bit up here. Uh, uh, yeah. Acha. So I move to the next slide now. Now look at this. How can you find the remainder using the same method? Let me write this question. This is from the next exercise, 1F. I'm writing the first
Sir,
question.
what did you mean? What did you mean? What did you mean when you said that it only works on a linear expression?
I am just going to explain this. Let me write this question. This is 6x cubed plus 3x squared, and this is minus 5x plus 2, and it is being divided by x minus 1. Okay, but when I say that it only works with the linear expressions, you must be now familiar with the linear expressions. The linear expressions, if I give you examples, this can be 2x plus 1, x plus 3, x minus 1, 3x plus 5. It can just be x. It can, so these are all linear. So if you want to, like, for example, you want to find the remainder, and if you're dividing all of this by, let's say, x squared minus 1 or x squared plus 1, like there's a quadratic or cubic expression. So this remainder and factor theorem is not for any non-linear expression. I hope I made it clear to you.
Okay, okay.
Okay.
ठीक है.
Now, when we're dividing this by this x minus 1, you will see that what will happen. Now, this is going to be f of 1. Okay? When you divide it by x minus 1, you have to find f of 1. Okay? So I'm just going to put 1 here. So this is going to be 6 plus 3 minus 5 plus 2. And this is going to be 9 minus 5 is 4 plus 2, 6. Now, this 6 is basically remainder. Okay? Let me show you through the division that how this is the remainder. And you have to be impressed by those mathematicians who have, like, discovered all these rules here. So there are people who, rather than wasting time, they develop these things. Okay, so x into 6x squared gives us 6x cubed and minus this 6x squared. So I change the signs here. This one is cancelled. So I have 9x squared minus 5x. So this will be plus 9x. This is 9x squared minus 9x. So I again change the signs here. This one is cancelled. So I have now, this is 4x plus 2. So I'll be using 4 here. So this is 4x minus 4. Okay, and this is going to be this. You see, after all this long division, you get the remainder 6 that you quickly got through this remainder theorem. Now, isn't it a cool thing, bacho? Anna? If we had that person in front of us, we could have clapped for that person. Okay, so this is how the remainder and the factor theorem works. If you want to determine that if a given divisor, this linear expression, is a factor, then this should always be equal to 0. If this is not equal to 0, that means I'm sorry, I should write here, if it is not equal to 0, that means that this x minus 1 is not a factor of this f of x. Do you have any question before I go to the next question? Okay, there was no question.
No.
Okay, so one more question here. It says, this is the second question from the, where is that? Okay, now this is the question number 2 from exercise 1F. Okay, this is your P3 book. Okay, bachos, so I should name this as f of x. This is x cubed minus 3x squared plus ax minus 7. And when I'm going to divide it by x plus 2, so basically I will be finding, yes, bacho, what should I write here? F of what?
-2.
F of
-2.
minus 2. Yes, this should be f of minus 2. If it was x minus 2, then this had to be f of plus 2. Okay? Okay, so now I should write it here that this is equal to minus 37. We are given the remainder. It says when all of this is divided by x plus 2, the remainder is minus 37. So like, you know, this is the equation that you have to learn. You must be writing it like this. This is written in terms of the remainder factor theorem. So when, for example, if you find somewhere written like this, f of 1 is equal to 2. So what would that mean to you? Come on, tell me. Who will interpret this? Yes, come on.
When you have a
It would
factor
mean that the polynomial divided by x minus 1 has a remainder of 2.
Excellent, beta. Excellent, excellent. That is exactly the correct answer. Like, you know, if it is f of 1, so that is, you are basically dividing it by x minus 1. So when you're dividing it x minus 1, and if the remainder is 2, so you would be writing it like this. Okay, now suppose you're going on a motorway and there is a big billboard, and there you find written that f of 3 that is equal to 0. So how would you interpret this thing, bacho? F of 3 that is equal to 0. What would that mean to you? Yes, anyone else? Yeah?
when you divide it by
-3 is a factor of the equation.
Exactly, exactly. Very well done. Like this would mean to you that x minus 3 is a factor of f of x. Okay, bacho, I hope you're understanding this new notation. So mathematics is basically a language, okay? So you have to understand that what do these sentences mean. So now coming back to this question now, f of minus 2, that was minus 37. So you change this x with the minus 2. So you have here minus 8. I'm not going to show all that working. This is going to be minus 12. This is minus 2a. You have to keep a check on this if I am making any mistake here. That is going to be minus 37. Okay, so minus 2 cube is minus 8. Minus 3 into minus 2 square is minus 12. You can show that step where you're substituting all these values. Okay, so this is minus 27. And this is minus 2a is minus 37 plus 27. So this minus 2a is equal to minus 10, and your a is equal to 5. So that is how we have found this value of a using the remainder theorem. Okay. So we have this question number 5. F of x is given as this ax cubed plus 7x squared plus bx minus 8. We have to find the values of a and b. We're given that 2x plus 1 is a factor, and we are also given that when we divide this by x plus 1, the remainder is 7. Now, this is basically a new thing. This is your skill to transform, to change these statements into the mathematical statements. So when it says 2x plus 1 is a factor, so that would mean to me that f of minus half is going to be 0. Okay? And when it says 7 is a remainder when it is divided by x plus 1, so I should write it as f of minus 1 that is equal to 7. But so you must have questions at this level. If you guys are understanding that what I have written here, that means you have understood the remainder and the factor theorem. Yes. I want your take, bacho. I want your concerns. If you believe that f of minus half is really equal to 0, because it was stated here that 2x plus 1 is a factor, And then this 7 is a remainder when f of minus 1, I mean, when x plus 1, it is divided by x plus 1. Okay, so keeping in mind that this after the equal mark is always a remainder here. So when the remainder is 0, obviously the divisor is a factor. Can I proceed now? If your silence, I'm going to take it as that you people understand that you guys have understood the new notation for the remainder and factor theorem. I'm waiting for you guys.
Yes,
I
sir.
need a signal so that I can go
Yes,
ahead.
sir.
Okay. So now if you're clear about this, then you can do it yourself, Bacho. Then there is nothing left in this question. So f of minus half is going to be simply a into minus 1 over 8. This is now up to you. How do you solve these equations? And this is plus b into minus half minus 8, and that is equal to 0. Okay, you can see that the 8 can be taken as the LCM throughout, so I'll be multiplying all of them by 8. So I will have minus a plus 14 minus 4b minus 32. That is the coolest way of getting rid of the fractions here. Okay, so we have I'm moving these a and 4b to the other side, so this is a plus 4b.
Why is it 32? Shouldn't it be 64?
Oh yes, thank you, this should be 64, Hannah. Yes. Thank you, beta. Dekha, the people who are not sleeping. This is 64. Okay, so this is going to be minus 50. Please keep an eye on my work. There can be mistakes. This is the first equation. Okay, now from this, f of minus 1. So that is going to be minus a plus 7 minus b minus 8. That is,
Excuse me, sir.
yes, beta.
Shouldn't that be 50? Because when you take it to the other side, it becomes 50.
No, beta, I have moved a and 4b to the other side. This remains on its side. Okay. Thank you, beta. Thank you for your alert attitude, beta. I really like this. Okay, now this 7 is cancelled with this 7. And this time, this is going to be a plus b, that is equal to minus 8. Okay, guys, I'm not going to solve these two equations now. You know how to solve them. Okay? So if you have books with you, I'm just going to assign you some work. You people should be trying the questions from exercise 1F rather than wasting your time on to exercise 1E. So please try some, let me pause this video here. And in fact, I should stop this